everyone. Welcome back to Learning at 11th Hour. Today, we are going to look at this very interesting topic called as the supermesh, which is an extension of the mesh analysis. So, this concept of supermesh, right? We use this whenever there is a current source available in our circuit. Now, why do we have to go for this supermesh analysis? We have to go for the super mesh analysis because we do not know exactly what the voltage drop across a particular current source is going to be. So, when that is unknown, we will not be able to resolve that particular loop using KVL. So, therefore, we tend to ignore the dependent or the independent current source available in the circuit and go for a larger perspective of the entire circuit and then apply KVL to it. So, let's look at some example problems in order to understand the concept of super mesh a little better. So let's look at this first case. In this case, we do have a current source which is available in one of the meshes. So when this is the case, we've already done one such problem in the previous video. Here, we are going to consider the two loops here with the two loop currents, but we know that the current I2 is nothing but 10 amps, which is nothing but the current coming out from the current source. So therefore, we already know the value of I2 over here. Now, having said that, so let's write that down. I2 is going to be equal to 10 amps. We are now going to apply KVL at the first loop. In the first loop, when we apply KVL, so let me mark the directions. So this would be the direction of the voltage drop across the 10 ohms resistor due to I1, and this would be the direction across 10 ohms resistor due to I2. So writing the KVL equation for this loop, we get minus 5 plus 5I1 plus 10 I1, which is pointing downwards, minus I2, which is pointing upwards. So the direction that we have considered here for the loop current and the direction of the voltage drop across the 10 ohm resistor due to I2 are opposing, which is why minus I2. So all this put together is going to be equal to 0. Now let's rearrange and simplify this. So what we get is we get 15I1 minus 10I2 is equal to 5. Now we know that I2 is equal to 10 amps. So 15I1 minus 100 is equal to 5, or rather I1 is equal to 105 divided by 15, which is nothing but 7 amps. So when we have a current source available in our circuit, then we have to see where it is located. So if it's a part of one of the loops like that, so then the loop current of that particular loop becomes the value of the current source itself. So this is the first case. Let's move on to the second case. In the second case, we have a current source connected between two meshes. So this is the first loop and this is the second loop. So in these two loops, let's just mark the loop currents as always. So this is going to be I1. I'm considering this to be I2. In this scenario, what we are going to do is we are going to ignore this current source altogether and consider a larger mesh, which I would represent by this dotted line like that. So that forms our super mesh, which consists of this 20 volts voltage source, the 2 ohm resistor, 3 ohm resistor, and this dependent voltage source, which is current controlled. So this is a current controlled voltage source. So all these four components is going to form my super mesh, where we have ignored the 2 amps current source altogether. Let us try to resolve this right now. So we can write the equation for this super mesh as proceeding in the same way that we usually do. So marking the voltage drop directions. So then we get 20 minus 20 in this case, because the direction of I1 opposes V1, and through 2 ohms resistor we have I1 flowing, so 2 I1 through the 3 ohms resistor, we have I2 flowing, and the direction of I2 and the voltage drop is in the same manner. So therefore, plus 3 I2, again plus 5 I1, because I and I1 in this case are the same, is equal to 0. So what have we done here? We have applied KVL for the super mesh, where we have actually completely ignored the 2 amps current source. So this forms my first equation. Let me simplify this. So I'll get 7I1 plus 3I2 is equal to 20. Now, we also know, looking at this current source branch, that is made up of I1 flowing downwards and I2 flowing upwards. So, this overall thing put together appears in this manner. So, we have um, I2 minus I1 is equal to 2 amps. So this is my second. So I could have taken it as I1 minus I2 is 2 amps, but then in that case, we would be considering that I1 is the larger value of current and I2 the smaller. But looking at the direction of the 2 amps current source, it matches the direction of I2. So therefore, I'm considering that I2 would be the larger value of current from which I1 is subtracted, because that's the one which is opposing. So now we have these two equations with the two unknowns. So simplifying this, what we will get is, we can actually replace the value of I2 in the first equation. So we can say that I2 is equal to 2 plus I1, and this we will replace over here. So what we get is 7I1 plus 3I1 plus 6 is equal to 20, or 10I1 is equal to 14, and therefore I1 is equal to 1.4 amps. So the question says we need to find out the current I flowing in this circuit, and according to the loop current that we have marked, I is nothing but I1. So this is the value of I that is flowing in this circuit. So the answer turns out to be 1.4 amps. So this was a question asked in 2019 GATE in the EE paper. Now, moving on to another problem. Uh, Here, in this example, the current source is in series with 3 ohm resistor, and this branch is in common between two meshes. So suppose I call this as the first loop, with I1 being its loop current, and this is the second loop with I2 being its loop current, and this is the third loop with I3 being its loop current. Then between loop 2 and loop 3, we have the current source and this 3 ohms resistor in common. So we can now clearly see that we can see frame a super mesh for this particular loop. So that would be the direction of my super mesh. Now we can write the KVL equations. The first one would be for the first loop. So KVL for loop 1. So that would be, again, let me mark my voltage drops. This is plus minus due to I1, and this is plus minus due to I3. In this 5 ohm resistor, this is plus minus, and this is my plus minus due to I2. So this is due to I1, and this one is due to I2. So let me write the KVL now. So that is minus 50 plus 10 I1 minus I3 plus 5 I1 minus I2 is equal to 0. So we can simplify this as 15I1 minus 5I2 minus 10I3 is equal to 50. So this is my first equation. Now we can apply KVL for the super mesh that we have considered over here. So the super mesh consists of the 10 ohms, the 2 ohms, the 1 ohm, and this 5 ohm. So we have, considering the super mesh in this direction, we have 10 into I3 minus I1 plus 2 into I3 plus 1 into I2 plus 5 into I2 minus I1 put together is equal to 0. So when we simplify this, what we would get is minus 15 I1 plus 6 I2 plus 12 I3 is equal to 0. So this is my second equation. We can now also frame two more equations. Uh, so the first one is that we need to find out the current through the 5 ohm resistor. So that is actually going to be equal to I1 minus I2. So this is the current that is flowing through my 5 ohm resistor. This is what we need to find out. And from this branch that we ignored for framing the KVL in the super mesh, so we can say that this 2 ohms is actually made up of I3 minus I2. So this forms my third equation. So having these three equations in hand, we can actually simplify the entire circuit and solve these equations to find out I1, I2 and I3. So on solving the three equations, we get the value of I1 is equal to 20 amps. The value of I2 is going to be equal to 15.3 amps, and the value of therefore I through the 5 ohm resistor is going to be I1 minus I2, which is nothing but 4.67 amps. So in this manner, we can actually resolve and find out the currents through different elements using the super mesh analysis. So that's all with today's video. So today we discussed the concept of super mesh, which was an extension of the mesh analysis, wherein this is a special case where we apply this concept for circuits having current sources. And we are going to completely ignore the current source and the element in series with it in case the current source is common to any two loops, or if it's a part of a loop, then the loop current of that particular loop is going to have the same value as that of the current source. Hope this concept was clear to you all. Please do subscribe to my channel for watching more such videos on concepts of the circuit theory. Thank you.